Here we go. Okay, here. So this is another one from the textbook. I think I use a different name, but I chose to use my name for fun, I guess. So we're assuming that Adam has $100 in his school account, lunch account that is. And let's say the school is charging $3.50 per lunch. We want to know how many lunches Adam can purchase, or can Adam purchase, right? Okay, so what's changing here? Well, one thing that should be kind of obvious, that's obviously changing, is how many lunches Adam can buy, right? That's actually what we want to know. So that's going to change. That can change, right? And also how much money he has in his account. You know, for each lunch he buys, he's taking money out of his account. Okay, so the number of lunches, that's a changing quantity. You know, he's not restricted to buying only one or only two. And again, how much money he has in his account. How much he spends, in other words. Okay, now, maybe not for this problem, but if it's really hard to understand what's going on, it's always good to do some number crunching. You know, that will help you understand what's happening. So for instance, let's ask, can Adam buy one lunch? Well, let's see. Each lunch is $3.50. So he would spend $3.50. Can he afford it? 100 minus $3.50? Yeah, he can afford it. He has money left over. Okay, that's fun. Can he buy two lunches? Not two more lunches, just two lunches. Well, he'd be spending $7, right? 3.5 times 2. So yeah, he could. He would have $93 left. Okay, now I'm not going to go through like 3, 4, 5, 6, and 7, but let's wonder though. Can Adam buy 50 lunches? I'm not saying he should, but can he buy 50? Well, let's see. Does he have enough? 3.5 times 50 is $175. So no, he can't. He doesn't have enough money. So obviously there's some limit in how many lunches he can buy. And they want us to figure out how many lunches he can buy. What's that limit? And also, I think they want us to know, I don't know if I wrote it, but how much he has left. Okay. Well, we have our variables, right? The number of lunches and the amount of money. What I'm going to do is this. I'm going to say, let's let X be how many lunches he buys. That's what we want to know. And again, it depends on the other variable, that is how much money he's spending, or in other words, how much money he has in his account. No, check that, how much he's spending. I mean, that's what we did with the number crunching, right? How many lunches he buys, how much money he's spending. Now, can we get M? We want to find X basically, but can we get M in terms of X? Well, yeah, we can. We know how much he's spending. Namely, M, how much he's spending, that's 3.5 times X. Right? That's kind of what we did. Let me see if I can get back to it. With the number crunching, right? How much he's spending. Right? That depends on how many lunches he's buying. So it depends. So that means it would be our output. And our input then would be how many lunches he buys. Now the dependent variable, remember, that's our output. Now, and we have a formula. From the number crunching, it appears that M should be 3.5 times X. Okay, so we want to get X. Well, what do we do? Well, Adam can only buy at most $100 worth of lunches, right? He only has $100 to spend. So in other words, we want X so that M is $100. That's the amount of lunches he can buy. The most amount, that is. So in other words, we X so that M is 100. Okay. So we want x, so that 100 is 3.5 times x. Okay, how do we do that? Well, that's actually pretty easy, right? You just have an equation and you just solve for x. So basically, we get x is about 28.6. Also notice I rounded to 1 decimal place. Okay, so does that make sense? That is that the right answer? 28.6. Well, can he buy half a lunch?
No.
No, he can't, right? That doesn't make sense. So what would the answer be? It would probably be 28. And he has $2 left over. Now, you probably could, if you wanted to be careful, that is, if you wanted to be like the book, find, the domain, I guess, but we don't have to do that. Okay. Right? So again, we want to make sure that our answer makes sense in the context of the problem. And we did. Okay. All right. So that one's good. All right. So are there any questions on that? Otherwise, I'll just move on. Not to another word problem, but to some backup stuff. Then we'll start the next chapter. Okay. So I'm going to move on to some new ones. These are other questions they have in the book. It's really just interpretation. But here they tell you that P of n is a function. And P of n is the wholesale price in dollars of a package of cookies after n packages have been sold. Okay, so now they're asking, well, what is this? What's the meaning of this? What does this tell us? Well, if you think about the problem here, we have n, our input is 124, right? Our output is 0.8. Well, by the problem, this is saying once 124 packages have been sold, the wholesale price in dollars of a package of cookies is 80 cents. So basically, it's just asking you if you understand what the function is saying. That's all it's doing. Nothing too fancy there. So, good stuff. Well, that was so much fun. Let's do another one. So this one also comes, look, I don't remember what number it is, but I don't think it's number 2. But this is the function d of h is telling us how many miles Billy has driven his car from his house, h hours, that should be lowercase a, after leaving his house. Let me just fix that. Okay, so h hours after leaving his house, d of h is how many miles Billy has driven. So they're telling us, okay, d of 4 turns out to be 160. Well, in the context of the problem, what does that mean? Well, 4 hours after leaving his house, right? He has driven 160 miles. Billy has driven 160 miles. Okay, that's cool. For this one, what about this? Well, this is saying 0.1 hours after he left his house, he has driven 2 miles. Now, could you convert 0.1 hours to minutes? Probably. I'm not going to do that, but we could. So, just, again, these are just quick backup questions. Hopefully it makes sense. I don't think it's too bad. Okay. All right, that's the end of chapter 3.